Okay. I love recording my lessons. It's so great. Okay. So a radical is this symbol here. So you're going to hear me say a radical a lot. Now, a radical is actually the same thing as an exponent. It's just a different way to write it. Okay? This, I read through this with another class. It seemed too confusing. So I'm just going to show you. Okay? This right here, the numerator is the same as the exponent in my radical. And then the denominator is the same as the type of radical. So maybe a square root or a cube root, okay? You guys remember what a radical is? It's how I split something, right? If I wanted the square root of 25, I'd say, okay, what number times itself twice gets me to 25? And it would have been 5 because 5 times 5 is 25, right? So a radical is like making the numbers smaller and the exponent's making the numbers bigger, right? Because it's this number times itself, okay? So these radicals are still exponents. They're just fraction exponents because they're making things smaller, okay? So basically all we got to figure out how to do is how to convert it. So if I'm going to convert this to a fractional exponent, then I know my b is my base. And then I know that my what the heck? Radical is my denominator. And my exponent is my numerator. So it'd be b to the 8/5.
So you're just turning these into fractions?
So all we're doing is converting it. Because I'm not going to make you do the exponent rules with fractions as exponents like they would in the other Sec 2 classes. All we're doing is showing you how to convert them. And then you could apply the rules if you wanted to, but I'm not going to make you, okay? So right now we're just learning how to convert, okay? Now on this one, notice the parentheses here. That means the 6 and the x both have to be put to the exponent because they're in parentheses, right? So we want to make sure we keep them in parentheses here. So 6x, and then it would be to the 2/3. The exponent is my numerator and the radical is my denominator. I'm going to come back to C, okay? I want to look at D. How is D different than B? The parentheses. So that 3 can't go to the 11. So what that means is that these are actually going to have two different fractions exponents. What is the exponent on the 11? Good. So it's going to be 11 to the 1/4 and x to the 3/4. That's different on this one, B, because they both need to have that 2/3 exponent. But on D, there's no parentheses, so the 3 only goes to the x, not the x and the 11. Good? Okay, E's a little weird too, because the 3 needs to have the same exponent, right, as the R. But the 2 here can't have any fraction exponent, right? Because it's not under the radical at all. So it's going to stay 2 to the 1st, even on the outside. And then 3R to the 3 over, those are both good guesses. Anyone else have a guess? One of those guesses is right. It's a 2. So every operation in math has an invisible number. So like exponents, it's 1, right? When it was the denominator, it was 1. Coefficients, it was 1. But on this one, when I have the 25 here, we knew we wanted to split the 25 into 2 of the same number, right? In radicals, it's like a little invisible 2. So this is like a little invisible 2, and so it's 3 halves.
Why can't they all just be the same number?
I know. There are even some that are the invisible number 0. It's whichever one is the invisible one is the most used one for that thing.
I'm still so lost on where the 2 came in.
Which 2? The little 2 or the big 2?
Little 2.
Okay, so what is the square root of 100? And you picked 10 because I needed 2 10s to get to 100, right? Does that make sense? Notice though, I didn't write a little 2 right here. You just knew that I was looking for the same number. Oh, you guys can't even see what I'm writing. Okay, so you just knew that in this one, like, okay, let's try this again now that you can see the screen, okay? Uh-huh. So if I have the square root of 100, I know that that's 10, right? Because I was looking for what number times itself twice got me to 100. So on this, the idea is that the invisible number for each math symbol is whichever one I'm using the most. So if I know I'm supposed to split this into 2 of the same number to get to 10, then I know that this was a 2 here, even though I didn't have a 2 there. So the invisible number for radicals is always a 2. Okay, so if that's the idea of what a radical is, do you guys know if there was a 1 there, what it would be?
It would just be 100.
It would just be 100. It's just the same, that's, because having a 1 there is saying, how do I get to 100 but only using one number? Well, then that's the 100.
Would 3 be 1,000?
That's a good guess. So on the, you have to go smaller. If it's a cube root of 1,000 would be 10 because 3 10s would get to 1,000. Does that make sense? But like if I'm doing the cube root of 100, I'd have to get the bigger the radical number, the smaller the number here would have to be because I'm looking for a number smaller than 100 to get to 100 by multiplying it 3 times. Does that make sense? Okay, good. What else? These are great questions, you guys. Okay. So let's go back to C now. Okay, I don't need any parentheses because there's only one base, the y. The exponent is the numerator, so 6. And then over the invisible radical number, 2. But this one is different than the others because I have to do something now.
You have to divide the 6 by 2.
Yeah, that fraction reduces. So y cubed. Because 6 over 2 is 3. Right? Hey, is F like B or D? Is the 5 need the fractional exponent or are they going to be different? Is F like B or like D? It is like B. Good. It's 5A to the 2/3. Guys doing okay? Okay, we're going to go the opposite way now, and then we're done with Unit 1 stuff. You guys are doing a great job, okay? Let's go the opposite way now. Okay? So this one, the denominator is the radical. So this would be like the second root of v to the first, or square root of v. Because for exponents, the 1 is invisible, and for radicals, the 2 is invisible. Okay? Is the 3 going to go inside the radical or stay on the outside? It goes in because it's in parentheses with the fraction exponent. So it would be the 4th root of 3n to the 7th. Okay, what about on C? Does the fraction exponent go to the 2? No, because there's no parentheses. So we don't even want it inside the square root. Or I guess I should say cube root. because it's not attached to the X with parentheses. Make sure you see the difference between B and C. Okay. I want you guys to try the last three. I'm going to walk around and check, and as soon as I've checked you gotten them right, then I'm going to hand out your homework. That's a wrap for Unit 1 material. Okay, so I'm going to come around and check the last three. And then as soon as I've checked that you got them right, then I will hand out your homework. Good work.